Okay, so last week we did a little bit of data preparation on how to clean up your data before starting the analysis. And we had one more notebook to finish on that. So we're going to do that. And then we're going to walk through a little example just to make sure that everything we learned last week makes sense. And then we're going to get into EDA and then visualization. Getting a little bit of echo from, I think, from Roni. I'm just gonna mute. There we go. Okay. Yep. So we're gonna go ahead and get started with the wrangling text. And this one, it might look a little intimidating. We're gonna walk through some regular expressions, regex, and it just looks a little confusing. So, but not to worry. We'll get through it. So yeah, gonna import our libraries that we're going to be needing. So pandas and NumPy. And then here's a data set that we're going to be using for this one. It's very similar to what we did when we previously dealing with pandas. So nothing new there. So some of the regular expression functions that are very popular, we have count, contains, replace, full match, split, extract, find all. And a lot of these do exactly what it says. So count counts the number of instances, contains does this string array variable contain a pattern, a word, whatever we're looking for. Replace, same thing as in Excel when we do find replace. Full match, so determines if the entire string matches the pattern, whatever we're looking for. Split, same thing as in Excel. If you do like data to columns, splits it into separate strings, depending on what the separator is, comma, column, space. Extract finds all the occurrences of the pattern and packages them into columns. Then find all finds all the occurrences of the pattern. So let's get into what regular expression is and the basics of it. So basically, what regular expression helps us do is use like wildcards. If you don't know exactly what you're looking for, or like you're looking for a pattern, for example, when it comes to trying to figure out whether a certain string is a valid phone number, a valid email, for validating passwords, does it include at least one uppercase letter? Does it include at least one number, a special character, and so on? So that's what you can use regular expression for. So matching complex text patterns allows matching, splitting, replacing, like we saw earlier. And there's a ton of documentation for this. This is definitely nothing that we're going to expect you to memorize how to do these. They even have websites to help you form the proper pattern matching. So don't have to memorize any of this. You will always have Google. And if one day you work for a company that does not let you use Google for your work, I would suggest to switch companies because that's a little crazy. Okay, so to get regular expression, we have a RE is the library. So import RE. And then here's a couple things that we're defining. So we have red, green, regex, match, and these are functions that we're going to be using here. So, and later here, so regex match, we're going to be passing in a string and a pattern. And then the result of this is going to be, okay, does this does the whole string match the pattern? So we're doing re.fullMatch. And then if result, so if this result's true, we're going to be printing out, so green string. So we're going to be passing in here. And then here's a strings that we're concatenating with, and then and then that's what it will determine whether or not things are matching. So here, when we run this cell, and what this is doing here, which I didn't actually realize, this is setting the text green, and then the string so matches the pattern. So C, does this match this pattern? And in regex, what this means is this string a capital letter between A and Z? And obviously C is a capital letter between capital A and capital Z. Then we have, does F match this pattern? So this one is all capital letters between A and C, which F is not between A and C in the alphabets, so this one does not match. Sitting here, we're going to be looking at 3, and since we're only looking at capital letters, this is not going to match. Then we're looking at lowercase c, and that also doesn't match. So with regex, it is like you determine case sensitivity there, and we'll go how to look at both. And the last example is a symbol, so a hyphen is also not part of this. And that might be like a little confusing because we see a hyphen here, but the way this pattern works is we're only looking at capital letters between A and Z. Any questions on this? And then to match both uppercase and lowercase letters, we're going to do A to Z and then A to Z lowercase. And that's how we get C matches it, and then lowercase c also matches it. But 3 still doesn't match it because, again, we're only looking for letters. To try to match for numbers, we'll do 0 to 9. So 9 matches this pattern of 0 to 9. C matches this pattern from A to Z, uppercase, A to Z, lowercase, and then all numbers. 9 does not match between 3 and 6, and C does not match between 0 and 9. So this stuff is pretty straightforward so far. Not too scary, hopefully. Any questions? And this is something, like I earlier mentioned, like you can use to like validate your data for, if you're looking for emails, making sure that all your emails are valid emails. And it's honestly, it's used in a lot of places, but that's like, as far as data cleaning and validation purposes, that's one use case for that. Then we can specify a set of letters, digits, characters. So right here, we're doing ACF289. So like, is this string any of these options? Same thing here, C, we have C in here. We do not have 7 in here, and we do not have G in here. So that's how you would match. That's how you would set the pattern to be very specific if you're only looking for something specific. And we're still doing the full match here, so not to forget that part, because we could also be the contains, which we'll see in a little bit. And then, so the brackets, it's like giving you the range, a character range, treated as letters and digits, regular expressions, match only those values. But we can also do, just without the brackets. So does Texas match Texas? Texas match Arizona? Does Texas match uppercase Texas? And again, we're looking at case sensitivity. So we're looking for exact match at this point. Then if we're looking for like a certain pattern, kind of like I was saying, whether it's like phone numbers. So with phone numbers, usually you're looking at like 3 numbers, a hyphen, 3 numbers, a hyphen, and then 4 numbers. Or you might have parentheses, 3 numbers, and then 3 numbers, hyphen, and whatnot. So that's how we can determine, like, if we're looking for a specific order of things. So here, the first letter, we're looking it to be between A and Z capital, A and Z capital, A and Z capital. So making sure that every single one of these is a capital letter. And then another way you can write it is just doing the A to Z, and then we'll do the squiggly brackets and 3. And then from here, to use 2, 3 to specify like minimum and then maximum of 3. So these are all matching. So here we get 2 hits, here we get 3 hits. And then here, the reason this one isn't because we're looking at like the first 2. So that's why that doesn't match. Any questions on that? Then if we're looking to match like one or more instances, we can use the plus sign. So A to Z, all capital letters, and like find at least one match on here. So we get AEH matches all capital letters. Same thing here. We find at least one number, find at least one letter, capital letter, or a number. Here it's not matched because we're only looking for capital letters. And then here we're looking for numbers. And then we can use the question sign to look at the we can have an optional digit in there. So here we're looking for a pattern. So like this one could be used for the phone number thing if we made it more numbers, but similar idea. So looking at one number, then any character in between, then looking for a match of 2 capital letters. And then here, looking for the numbers, and then at least 2. So yeah, so the optional digit in front of 2 uppercase letters. So this one, yeah. And this one, we don't have 2 uppercase letters. And then this one, we also don't have 2 uppercase letters. Good so far. And yeah, this starts to get like a little crazy. You start to throw in like different symbols, how to match different kinds of patterns. So it can definitely seem a little intimidating. It's nothing you have to memorize. Like I always look this up, and these days you can ask for a program to tell you exactly how to do the pattern. The dot represents a wildcard character, matching any single character, including non-alphanumeric characters like punctuation and symbols. If you intend to match a literal dot, then we'll put the escape lash in front of it. And this is, we see this in like programming. I think we saw it earlier with string formatting. Whenever you're trying to do symbols or like return character or whatever, we're going to be using the escape slash to kind of make it ignore things or tell it to do symbols. For example, when we were doing, if the whole string is in double quotes and then we want to include a double quote inside the string, you would do the slash, the escape slash in front of the inside double quotes to make it ignore. So you'll kind of see that across things. And again, we can do the quantifier here the same way as before. Again, here the plus sign. So similar stuff. Did I lose somebody? And then The last operator that we're going to look at is the grouping of parentheses and then the alternator. So if you only want to match airport connections from ABQ or DAL to HOU or PHX, we can express it this way. So what this one basically says is ABQ or DAL. And then same here, like either ABQ or Dallas to Houston or Phoenix. And this is the same thing that you can use as an OR operator just in Python in general, instead of writing just OR. And in like Java, they do 2 of the pipes, and that's an OR. So that's one way to remember that. And here, neither one of these is Phoenix, so this one doesn't match. Neither one of these is Dallas, doesn't match. There's a thing here, things do not match. Any questions? So here is like the partial string matches, what I was talking about earlier about like validating an email. So this, we're looking at the data set that we loaded previously. Let me print this up actually here. So PDF. So this data set. So we're going to be looking at the email column. So DF email string, does it contain outlook.com? And here we're using the escape to make sure that it's properly using the period in here. And then regex equals true. So matching it. And then this one is going to show us every single record where the email matches this regex that we're passing in. So here we see we only have one. So number 7 is an outlook.com. We had this one here too. Oh, did we not? Yeah, 16. Yep, 16. Yeah, so only 2 in this data set. And then one of them is a null. So we want to handle that with the NA equals false. So this one gets us just the records, ignoring the null values. So these are the only 2 records that we have that match the outlook. And that's how you can filter and wrangle your data set. And here, so full string matches. So hunting down invalid IP addresses as an example. So here our regex is, so if you've seen an IP address before, we have 3 numbers, period, 3 numbers, period, 3 numbers, period, 3 numbers. Max 3 numbers. It can be less than that. So here, that's what it's saying. So we're looking at 3 numbers, at least 1, max 3, period. Same thing, 3 numbers, or minimum 1, whatnot. And looking at our IP address. So here's our IP address column. So here we can see, this one has 3 in every single one of them. There's 2, here's 1, and those are valid. So looking at full match. So every single one except this one here. So 27, I think this one. So this was not valid because we have more than 3 numbers here and more than 3 numbers here. Here's the phone number example. So 3 numbers, hyphen, 3 numbers, hyphen, and then 4 numbers here. So looking at these ones, not valid phone numbers here. We have, this is correct, but this one has 5, 3, 2, 4, not valid, and then 2, 3, 4, not valid. So this is how you would be matching a phone number. So yeah, it starts to get a little crazier, as you can see. And when you're more complicated things you're looking for, the more complicated it gets, and you not necessarily can memorize all the ways to match things. So yeah, so this one we're excluding the ones that are. And the reason, so all these, we have the question marks and whatnot, because this is also a valid phone number here. So we don't have the hyphens here. And then here we have the parentheses. They're also optional. So so this one matches like all possible phone number patterns. Versus like if you were to you only wanted all of them to be here, we would remove the parentheses from here. Or, and I think there's a space as well. So this is also a valid there. So now our data set only includes valid phone numbers and then IP addresses. And then let's identify all the invalid email addresses. So again, here, any number of letters, numbers, and then we're looking for the @, and then this one needs to be dot something. So here we can see we're missing one, so that obviously doesn't match. And then this one doesn't have anything after the @. And here periods are allowed, so this is fine here. Any questions? So yeah, so find 2 email addresses. So this one's just going to exclude them. And again, this is kind of like the last part. I think the initial thought will be like, oh, you want it to be only like 3 letters because you're thinking about like .com, but then like in Finland it would be .fi, it could be .net, different kinds. So you don't want to exclude things like that because it can be, which it can still be invalid address technically if it was .something that doesn't exist, but this is kind of, we're looking at the valid pattern at least. Finding all matches. So looking at extracting all the email domains. So here are all the domains from the emails. So find all where the email, like get the last part of the email. Where is it? Just the like letters and then dot, whatever. That's how you use to find all. If we want to gather the unique domains, we can join the lists of single items into string and then qualify the unique values. So finding, again, so that way we'll only get, we don't look at these. They're all duplicates. So rand@mail.com, outlook.com, hamiltonco.org, protonmail.com, Gmail. So those are all the unique domains that we have in the data set. Then we can replace matches. So here, so removing any of the dashes or parentheses spaces for the phone number. So this way we literally just get just the numbers. And that way they're all uniform. Or we could also replace all dashes or like all spaces with a dash and like just get rid of all the parentheses to get all of them to be the same pattern of like 3-3-4. And then lastly, we can split the text. So splitting the columns, expand true, which means we're splitting them into same thing as in what Excel does, text to columns. So this is the first part of their email, and then that's the domain. So these are all not all the ways, but the most popular ways that regex is used for. Don't have to memorize all of this. just kind of knowledge on what all this library can do. And we'll go through a little data cleaning example. So I have a data set, company operations.csv, which was an example in one of these notebooks that we looked at last week. So I'm importing pandas. And so what you're seeing here right now, this is also Jupyter Notebooks or Anaconda Notebooks, Anaconda Jupyter Notebooks. This is just my local distribution, but it's pretty much the same thing as here, but this is just locally. And we can walk through that if you guys want to see how to set that up. I prefer it to, I feel like it's easier because dealing with your local stuff and whatnot. But yeah, so this is the whole data set. I want it to be like manageable so you can kind of see the whole data set at once and we're not dealing with like hundreds of rows. So what's something that you guys notice about this data set when you first look at it? You can put it in a chat or you can just say it, whichever, but what does it need cleaning or wrangling or whatnot?
Duplicates.
Okay, we got duplicates. So here we can see a couple.
And some empty fields, like
Yep.
NEN fields.
Yep, we have no values here. Anything else?
Something's not capitalized.
Yep. So we have a little bit of formatting issues here. Same thing here, everything is uppercase. We kind of want everything to be standard. And then I'd say one more is with the zip code. That's obviously not a decimal. So those are a couple of things that we want to look at. And here, if we look at so if we sort this, we can see the duplicates a little easier. So we have Alpha Medical here twice. And then we have the Facility 95 here twice. So let's take care of the duplicates first. So what we want to do is get rid of the duplicates. So we saw last week that we have the function df.drop duplicates. But one thing that if you guys notice that our customer ID is actually still unique. So if we saw here, we have 7 and 8. So if we were to just do like df.drop duplicates, nothing would be dropped because it is treating every single, like it's looking at every single column when it's checking for the duplicates. So something that we want to do is check for the duplicates without including the customer ID. And the way we can do that is, so we'll do like columns to check equals df columns. So we're looking at the data frames columns, and then we can use difference to like the way it works in math. So difference. So get everything else except customer ID. So this is how, and if we were to look at this calls to check. So this one includes address, category, customer name, state, status, and zip. So that is all the other columns except the customer ID. So now we can pass that in. So df drop duplicates, and then we're going to use subset, which the subset tells us, hey, only look at these columns. And we could do that based on just one column, but in this case, we want to look at all the other ones. So subset equals calls to check. And then we'll do in place true, which means it's going to do it to the original copy of the data frame. And then we'll look at df. So now we see we only have one Facility 95 and then one Alpha Medical. This one, oh, so this one doesn't actually, yeah, so it's still thinking these are different because of here. So what we have to do here first, well, yeah, we'll actually do this later. I didn't realize I changed this because, yeah, anyways, we'll see that later. Sorry about that. We'll change it to the proper sentence case or title case, actually. Okay, so let's deal with the null values next. So if we wanted to see all the, like, look at the kind of like the overall view of where do we have null values in here, we can do the df.isNA, and this is going to show us everywhere in the data set. So we have true, 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 and true. So those are the 4 spots that we have a null value in our data set. If we wanted to look at only the records that have null values, so df and then df isNA dot any, so any match, and then axis equals 1. Oops, axis equals 1. Oh. Missing, where am I missing this one for? No, we need only one. That's right. So this one shows us the records. So this one means the axis equals 1. It means by the row. So customer ID 2, 3, 4, 9 have null values. And then this one just we're looking at with the rows with full null values. So same thing as here. If we didn't want to like look at the actual records, we can just say like, oh, which one of these have the null values in here. And then columns, we just do the opposite. We do axis 0. And then we can see that state and zip are columns that have no values. So what are we going to do about this? So there was a couple of ways that last week we were looking at how to deal with null values. But to begin with, I think the good way would be to like set the numeric columns to 0 and then set text columns to unknown. Since our state, if we don't have a value there, we can't really just, oh, like let's just put a random state there or like look at what the neighbors are or whatever. We can obviously do this by looking at the actual address and the zip code and then like going and finding what the state is, which we'll do it at the end. But to begin with, we'll just fill these out with the 0 and then unknown. So how we're going to do that is, so df zip, so that's our zip code, df zip, so our column zip code, I have an extra one here, and then fill NA, so fill the null values. I'm going to fill it with 0. And then for the state, same thing, df state, fill NA, but we're going to put unknown. And then we'll take a look. Is this, by the way, is this text big enough for everybody? I didn't ask that. I'm making sure that everybody can see this because I think that was a discussion last week. Hopefully it's all good. So yeah, we'll look at our df. So now we have zeros here in zip codes, and then we have unknown for the state. And that is a little bit better than null values. Last week, one thing that we were looking at was like when we're doing data analysis and like trying to draw conclusions, look at patterns, trends, whatnot, you have to see like what data is important. So here we can see that like status column, every single one has the same value. So like that's not really gonna do much for us. So the way we can check which and unique. So this one shows us the count for each. So customer ID has all unique values. And then status, we only have one. So we don't really care about that column. It doesn't add a whole lot of values. It's the same for every single one. So we know it's status. So how do we define which columns we want to delete? So we'll do calls to delete. And then here we're going to be using a lambda or a function for each row. So column for column value in, and then we do the zip method for df columns using the df in unique equals, sorry, this one, if value equals to 1. And I have an extra one. Let's see, oh, zip. This one is extra. Yep. So this one, we're defining the columns to delete. And then let's see, delete, oh, sorry, calls to delete. And we get status. Question?
I just want to verify is when you have CV, is C for column and V for value?
Yeah, so, well, so it's in when we do the df.unique method here. So we have the column here, and then this is the value for it.
Okay.
So looking at the column name, if v equals 1, so here. So that's what this is checking.
Okay.
And that's how we get, so columns to delete, we get status. Good. Anyone else have a question? And then we want to drop the selected column. So df equals df drop, calls to delete, and then axis equals 1. And then look at df. So now we get rid of the status column here. Okay, and then getting into formatting data. So looking at let's check the column types first. So if you remember from last week, we can do the df.dtypes, and that's going to give us what each column is. So we see customer ID is an integer, customer name, address, state, object, zip is a float, category is an object, and objects are fine here. But what we don't like about is float, because we don't want to represent zip as a decimal because it's not. So formatting zip as an integer, we're going to do df zip equals df zip, and then as type an int. And that's how we're going to make sure. So here we see we got rid of the decimals, and then we can even look at it, check the df dtypes again, and we see that here is an integer now, and that looks much better. Then we notice that there's some formatting issues here with the address. So here's all capital, here's all lowercase, here's some weird stuff going on here. So we want to set the address to a title case. So again, we're going to do df address equals df address, and then str, so we're dealing with a string, title. So this one is going to set it for a title case. So now we can see this looks better, this looks better. Everything is nice and uniform now. Only thing is this one, actually. And that one, we could use like regex to deal with that one. We're going to ignore that for right now because I don't want to get into all that. Another thing that I want to do here is separate the city to its own column. because that's how usually we see it represented in data. It's not really with the address line, or like it's not with the house address. And we want to make sure to maintain the original order of the columns. So we want to get the city between address and state instead of like being at the end. So first, what we're going to do is split the column. So doing column to text to columns. Is that what it's called in Excel? I think. So df, and then we're going to select address, and then city, not select. So this is defining, hey, for these two columns, and we don't have a city column, but this is how you would add a city column. df address, so looking at the address column, str, the string, split, we're going to split it with a comma, and then expand equals true, which means we want it to split into two different columns instead of just giving us like just one column. So df, and so now we see we have address over here, and then we have city at the end. That we don't want it to be at the end. So we're gonna reorder the columns to the original order. And how we're going to do that is, this one's like kind of lengthy, especially like if you have a lot of columns. This one's like really annoying, but you literally just type out every single column in the order that you want them. I'm just gonna copy these because it's gonna take way too long. So we want it to be customer ID, customer name, address, city, state, zip, category, and we no longer have status. And then we're going to apply. So df, so our data frame, we want it to equal to data frame and then column order. And that's how it's going to apply the order of the columns. So now we get address, and then city is nicely in between there. Okay, so, and now actually, like before we even did this one, we still have the alphabetical, so we can redo what we did in the very beginning. And ideally, we would actually want to do the title case before removing the columns, the duplicates. So let's see, top duplicates. So again, we're gonna do this thing, and then drop duplicates. Actually, we don't have to redefine this one because we've already defined before, but we do want to have we do actually have to define, no, yeah, we do, because we have a city there, which it's not going to make a difference really. So I think this one would still work. No, it wouldn't, because yeah, status, oh, yeah, so we do have to redefine this because we dropped a column here. So this way, let's make sure that this one is doing the right way. And then do cost check. Address, category, city, customer name, state, and zip. And then drop. Oops. Okay. And this one, yes. df, close df. So we could do, well, this one, it doesn't really matter. So now we don't have the alphabetical twice here anymore. So now it's looking good. So lastly, what we can do is let's fill in the missing state and zip, because that is information that you can find out without having access to the original data set. You could technically, like you can look at the zip code, and then you can also look at the address. So here we have a dictionary mapping state. So this zip code maps to LA, this zip code maps to LA, and this address maps to this zip code, and this address maps to this zip code. So, and this one, is going to, don't get intimidated by it. It's going to be a little bit of code. We're going to be using a lambda, and then we're going to be using an if-else statement. So what we're going to do is df. So let's take care of the state first. So df state equals df apply, which allows to apply a function for each one of the rows. So apply lambda row using our dictionary mapping state get. So when we're using a dot get, it's going to get the value if it exists. And if it doesn't exist, we're going to define a default value. So we want to get from this row that we're currently looking at when it's running through it, get the zip. So get the zip from mapping state dictionary if it exists. If it doesn't, then we're just going to leave it whatever currently is in the state column for that row. But we don't want to like do this for every single one of, well, technically we could, but just to define it further, we only want to do this if row zip is in mapping state. So we're only looking at values that exist in a dictionary. And then we have currently, so in state column, that one currently equals unknown. And if it doesn't, then we're just going to leave it as it is, as whatever value currently is in state. And then, let's see, I think we should have everything correct. Get, yep. No, where we go wrong? Oopsie, yep, have to run these cells first. The easiest mistake to make in Jupyter Notebooks. So, and this one, okay, yeah. So this is, it still does it when it gives you the warning. It's like saying like, oh, try using the .loc. I'm like pretty terrible at making this mistake every single time, but it still does it. So we see LA is filled in here and LA is filled in here, which we previously had unknown here. So sometimes you get warnings and you can just ignore them. And sometimes you should take a look at them. And then for the zip, we're going to pretty much use this same exact thing. So df, but instead of state, we're going to do zip. And then mapping, what do we call this? Mapping address. Mapping address. And we're going to get address from the address dictionary. If it's not there, default value is going to be whatever the zip value is. And only if the address is in the mapping address dictionary, and then zip equals to 0. Else, we're just going to leave it as zip. And it's also going to give me the warning, which I feel like it wasn't giving it that to me before. So here, now our data set looks much better. Anyone have any questions? And I'll make sure to drop this notebook also in the share folder, and I can put it in a way that you can try it yourself, and then I'll include like an answer key as well if you guys want to go through this on your own. Any questions? Okay, so we are going to, well, let's do a little bit, actually, what time is it? We'll take a 10-minute break, and then we'll get into the review on this notebook. So be back by, oops, 7. 5 p.m. Central Time. Yeah. All right. Okay. Hope everybody's back. So we're gonna go do a quick review. Can you guys still, hopefully, you can still hear me, right?
Yes.
Perfect. Okay, yeah. So quick review of kind of what we've done with the data cleaning and preparations. So with the pandas, pd.read CSV, that's how we're going to be importing a CSV file equal, so df equals pd, we get our data frame. So some of the functions, what we did here, did everywhere else. So dropping duplicates, sorting things, splitting, formatting, setting the proper data type, dropping columns. Those were some of the other functions or the functions. So we'll be looking at data analysis, visualization, and then analytics and reporting later on. And specifically today, we're going to be focusing on data visualization, looking at Matplotlib, Seaborn, and Plotly, very popular visualization libraries within Python. So our new data checklist, whenever we start looking at importing pandas, looking at the head, looking at the data types, then .shape, that one would give us the number of records and columns. Checking where data is null, looking at the values, and then data.describe would give us the mean, median, min-max for each numerical column. And then always can use help to figure out what all is possible. So whenever we're doing data cleaning, so what questions are we trying to answer? How does this translate into data cleaning? Filling the nulls with mean or average, filling them with something that makes sense that can allow us to analyze it properly, or then filtering out any null values, create different functions. So some of the questions like what are you trying to accomplish? What tools do you have? So that's what we did with the data cleaning. Then we have EDA, exploratory data analysis. So performing that on new data set is to understand the data and identify patterns, relationship, anomalies, helps us identify missing values, outliers, and any other data quality issues. So, it overlaps with data cleaning. You have to do EDA before or during when you're doing data cleaning to properly get the data ready for analysis. And then obviously want to visualize because that's going to help us to better understand the data we have and especially help the less techy people who make business decisions to understand, and helps us show trends, patterns, anything. The types of visualizations, which you took data visualization, so in Tableau, box plots, histograms, run charts, Perto, scatter plots, different kinds of ways to visualize. And we're going to go see that with the notebooks. And I also included here Plotly documentation. So I think Plotly is I think it's probably the most popular, at least that's the one that I've heard the most. And they have a really nice documentation with a bunch of different kinds of examples to how to represent data for each chart, statistical charts. So we can go look at here and it's going to show you how to zoom in. So yeah, it's going to give you simple code to do this. So yeah, and there's documentation for Seaborn and Matplotlib as well. So let's see, okay. So how to read a plot, and hopefully this is big enough. Let's see. So get started with a simple plot. So from Matplot, so importing matplotlib.pyplot as PLT. This is kind of like another thing for like pandas. We use PD. NumPy you use PD. This is or NP, and then matplotlib is usually PLT. It's kind of like custom cross. So this is how we can create a figure containing a single axis. So figure and ax. So this function right here splits out like two variables. So we're going to get the figure, and then we're going to get the axis for this figure. So plt.subplots, and then we can set the size to 14 by 5. Then here, x.plot, we're going to put some x values and then y values here. And running, and run this first. So here we can see, so x, y, 1, 1. Then we have 2, 4, 2 and 4, 3, 2, 3, 2, and then 4, 3. That's how you plot data. So very simple example. So let's look at the anatomy of the figure. So there's a lot of things going on here. So this is the figure. So what we have, fig size. We have the title. We have the legend. And this is the same thing as it will be in like Tableau. We have a minor text, major text labels, Y label, y-axis, x-axis, x label, and here's minor text for the x-axis. And then this is the spine. We have the grid to determine whether or not to show that. We have a line here, and then we have the markers here. So there's kind of some of the things that we can put on a graph, a chart. Any questions on this? I know it looks like a lot of things going on. So looking at the basic syntax here, so there's two coding styles. There's the object-oriented style, where we explicitly create figures and axes and call methods on them. And then they have the pyplot, matplotlib-like style, where we rely on the pyplot to automatically create and manage the figures and axes. But we're going to be focusing on the OO style here. So plt.figure returns an empty figure. So figure equals plt figure. And again, we're doing a 14 by 5. And this just means that's the figure. So at this memory axis, there's no axes. And then creating a figure with the axis, we do plt.subplots like we did earlier. Figure ax equals plt subplots. And now we can see our empty figure here. So, and to see how this works, so this is how you can see all the ins and outs of this function. So we have our signature, so ax.plot. We have our args, scale x, scale x, scale y data, and then we have the key KW args that we went over in the very first class. And the docstring, which is what tells us what this does. So plot y versus x as lines and our markers. Simple to call the sample signatures. And there's a lot here, so we don't need to look at every single thing. But this is just how you can figure out what all it can do, how to exactly use it. So it's going to tell you all about it. So plotting labeled data, plotting multiple sets of data, shows examples, the parameters, data, then what it returns, properties, formatting strings, markers, different characters you can use, line styles you can use, formatting strings, and the colors you can use. So a lot there. Don't have to memorize any of that because it's accessible by running that method. But that's how you access it. Okay, so here again, we're creating a figure containing single axis, and we're adding only y values. So this one looks exactly the same as before because it was, well, it looks the same, but it's actually not, because here we're treating so from 0, 1, 2, and 3. So that's what it's just setting it as a default for the x-axis. So this one's the y values. We have 1, 4, 2, and then 3. And this is the way we can set. So if we look at here, we're actually using 1, 2, 3, 4. So 1, 2, 3, and 4 for x-axis, and the same values for y-axis. And again, here we can look at more of the methods. This is how. So this is the line chart. That's like the default dot plot gives you a line chart. And then we can do dot scatter, which is going to give us a scatter plot. So again, same values as before: 1, 1, 2, 4, 3, 2, 4, 3. We can also do a bar chart, so dot bar. So same values again. So 1, 1, 2, 4. And this is we're just going over like all the possible things you can do. I know I didn't say this, but this one is from the data visualization. And I think I had it up on here, but I did not. Let me put that in here. Visualization. Intro. Yeah. Introduction to data visualization. That is where these notebooks are. If anybody wants me to walk through that, I can. But yeah, I'm basically just going over like all the possible things that we can do with Plotly. So yeah, there's not too much to like necessarily to run on your end. And then how we can do so to start kind of formatting the graph by adding an X label. So naming it time, adding time here, and then setting a Y label. So this is how you just do it. You do this x.set X label, x.set Y label. And now we have cost and time. Then we can add a title. This is all the same. Adding a title, .set title, simple plot. So yeah, every single thing needs to be like added on its own by calling it on the X. So here we want to format like the line. So dot plot gives us a line chart by default. We want to be pink. We want to use the plus sign as the marker, line style as dashed, marker size as 12, and then line width as 3. So those are some of the ways you can format the line. So now we'll see. We have a pink line that's dashed. We have the plus markers. It's maybe a little hard to see. See this is yet. But yeah, that's how you would format the line itself. And then we can add 2 lines. So by calling the x.plot and then putting different values in here. So, and then here at the end, we're also adding a legend here. So now we have data 1, data 2, one line, another line, different markers, different colors. So X, Y, simple plot, and then our legend is there. So here, marker plus, marker O, or circle, pink, red, using dash for both of them, marker size and line width the same. You can play around with this. And what we were looking at earlier when we did the x dot plot question mark, it'll show you the options of like, oh, what all can you use for markers, for line style. So you can play around with that. And one thing to notice here, so talked about in the very beginning of, we don't have like curly brackets or anything else. Like Python is mostly just using the tabs, so the indentation needs to be proper. But with this, we need to have the semicolon here, because if we don't, we will just like see the object representation. So this is where we can get to show it. So it needs to be at the end of each line for when we're dealing with the figures. Any questions on this? And there's other things that you can do, but here's just some few things what to do with Plotly specifically. Any questions? And then, so moving to the next one, this one we're pretty much like gonna look at, so plotting things with pandas. So again, like there's different libraries to do visualizations with. So that was with Plotly. So matplotlib, matplotlib.pyplot, actually, yeah, PLT. And then we have pandas is a different way. So same thing as we've seen earlier. So import pandas is PD. Then we're going to be using this. This is like a car mileage data set, looking at the head of it. So dealing with different cars, what their MPGs, cylinders, origin, whatnot. Give a shape, and they describe. So this is what we were doing previously. Using count, mean, standard deviation, minimum. And that's just, helps you figure out what you want to start visualization. Looking at our columns, and then you can access like the columns just by like dot name of the column, but this one is, I think, a little more standard to use it, how we've been using it. So this is the same way. You could do df.weight or df bracket, put a string of the column name. Get the mean of the weight column, standard deviation of the weight column, counts for all the origins. So USA, we have 249 records, Japan 79 records, and this is just, yeah. So let's look at plotting. And so df.plot gives us, so what this does is each line is a column, as we can see here. So over here. So weight here is the purple line. We have red is the horsepower, green displacement. And so this is for like, it's plotting every single record on this graph, and each column is a line. So that's like the default that dot plot does. The same thing we can do the df.plot question mark, and it's going to tell you all you can do. So with the parameters, the kinds of plots to produce, line, bar, bar H, histogram, box, KDE, density, area, pi, scatter. What layout, figure size, title, grid, legend, xticks, and so on. So it tells you everything that you can do with that function. Lots of stuff. We don't need to read all of it. So let's see. So we'll look at the head again, and then so you can create a histogram. So let's create a histogram with the MPG column. So df mpg dot hist, and then grid just enables the grid on here. So the grid values or the grid here. So we can see that like most of the cars in a data set have an MPG around 15 and 20. Majority is over here. We have very few cars around 10, and then like between 40 and 50. And if we didn't, I think so the default is to not have the grid. But if you include the grid, then you get the grid lines. This is the same thing without the grid lines. And then we can also do it with 2 different variables. So now we have a histogram for the MPG, and then we have a histogram for the horsepower. And this is, so using the subplots equals true, that's what separates them into their own figures. So if we were to take this out, we would get them in the same figure here. So depending on what you're trying to do. So if we wanted to look at like what the distribution of miles per gallon is by origin, we can do df.group by origin. We're looking at the MPG dot plot, find this histogram, and then alpha. This defines the transparency of the data, like the visual, like the graph, and then including legend. So here we see for Europe, Japan, USA. So what this tells us is that we have the highest miles per gallon in the US. And then here we have Japan in orange, and then Europe is in blue. And this is what you can, the alpha adjusts like the transparency of each one of them. That's why you can see them overlapped. Any questions? And there's something called kernel density estimate plot. So in statistics, kernel density estimation, KDE, is a non-parametric way to estimate the probability density function, PDF, of a random variable. So that if you're not a math person or a stats person, that's probably a lot of words. But basically, this method is useful for like smoothing out data to see like underlying trends without assuming any particular distribution. And we don't have to know like understand this fully. It's just a thing that you can do with the when plotting here. So this is when we do plotting the KDE on the miles per gallon, this is what we get. And then again, we can do it group by origin. Oops. And we would get this. So again, we're looking at it for Europe, Japan, USA. So this is just one way to look at it. So yeah, let's see. Again, looking at the head. Then getting the counts. Similar before we were looking at. So df origin. So the origin column, get the counts for each one of them. USA 249, Japan 79, Europe 70. And then if we want to plot it, we'll can do a bar chart. So kind is bar. And all we did here is like data frame or like the columns of data frame, get the counts, and then we do dot plot. and it's going to plot it for us. And then if we wanted to, so the default is the vertical, but we can do bar H is horizontal. The same thing, but in a horizontal. So then if we wanted to do a bar chart to show as we're going into origin and model year. So grouping by model year and origin, they want to get the average mean of the miles per gallon, and then on second origin. And this one also, this is good to put like numeric only, because like if you have null values or if you haven't done proper data cleaning, this is going to help you avoid some errors. So this one we assign to table, and then we're going to do a table.plot. And using a stacked bar chart to model year, and then miles per gallon for each origin. But there's a lot of things you can do with pandas, Plotly, then we'll look at Seaborn next. Of course, we have pie charts, which potentially learned in data visualizations that pie charts, it's like one of the worst ways to showcase data, because like even though we have only 3 values here, the USA, Japan, and Europe, you can't really tell which one of these is bigger. And it's better like if you put labels on it, but generally it's not the favorite way to showcase data. So if you can think of a different way to showcase the data instead of a pie chart, I would recommend doing that. Usually there's a better way to showcase it. But yeah, so this one was dot plot kind equals pi. And we're using the same data as before. So then looking at relationship between 2 variables. So df.plot, x is going to be weight, y is going to be miles per gallon, using a scatter plot, and then title. So here we can see like when we're dealing with pandas, you can kind of like set the whole thing at once, versus when we were doing before, you did like, you created the figure and then you were just like setting things line by line. And yeah, so here, so this one creates this plot. We have the weight, miles per gallon. So we can see as the weight increases, the miles per gallon decreases, which makes sense. And this is a different way. So using Plotly here, what we were doing before, we would have to do and we can do it, no, here, so subplots. So here we're doing, and then we're setting the plot in here. And here we're doing, again, kind, x equals x, color, setting the color for, so red, green, blue, and this just gives us the same as this one, but this one is not per origin. Any questions on this? All kinds of fun ways to do. I'm sure you've seen this, similar things in your visualization. Now you just get to do it with code. Then we can do a time series using a different, so it looks like air quality data set. Let's see. So we have just a bunch of, looking at air qualities, looks like Antwerp, Paris, London. Plotting it, we just get this. This is the default. Or then we can do each one to have their own. And that's just how you would, so the time. So this one, again, we did it by, since the way the data is formatted, it just kind of did it for us. We didn't have to like define the because the date and time is the index, so I need to use that for the x-axis. And then obviously each column we're using is the line here. That's how you would do time series. And if it wasn't like the date and time wasn't the index, we would have to like define it to get it to show it like that. Any questions? And again, this is just different ways to do things that are possible to do with visualizations in Python. And then next we'll look at Seaborn, which is just another library. They're both built on like on top of the Matplotlib. So yeah, so Seaborn provides high-level interface for drawing attractive and informative statistical graphics. Syntax is simple and easy to use. And then here's also their, let's see, example gallery. The same as Plotly has. Here we can see all these ways, different ways you can, what all you can do with this library. And so Seaborn is usually, its alias is SNS. Not sure where that has come from because Seaborn, we only have one S and one E. And pandas, and then let's see, what are we using here? Okay, we're using the same data set as before. So Seaborn lets you set the theme. So it's just like the default theme. And I think you can set it to be different things. So just defines like the color scheme and stuff. So here, sns.barplot, x equals 1, 2, 3, y equals 1, 3, 2. That's how you create a bar plot with SNS. So we have axis level functions plots data onto single axis object. So sns.histplot, passing in data, df, x-axis, and pg. And now we have a histogram. And this one does it automatically renamed y to count. Then we can do, so here we can do the KDE over it. We'll see it here. Then we want to do a scatter plot. We do dot scatter plot. X equals weight, y equals MPG. So same thing as we saw earlier. As the weight increases, MPG comes down. So just a different way to do the same plot, basically, or the same figure. Then here we can do, so hue is basically that determines when you want to color the different. So based on origin, like set the color. That's basically what this means. But we're using the same thing. So histogram, MPG, KDE true, and then setting the title, distribution of miles per gallon by origin. Now we have a pretty graph. And then, is this not the same thing? Oh, this is, I think, just, oh, scatter plot, yeah. So histogram, then we have scatter plot, same thing, using the hue. And this is what we saw earlier but we had set colors ourselves. And this is like the colors are because we set the theme to like the default SNS theme or whatever. That's how it's determined, like the colors. And I think there's like different themes you can set it to. So same thing what we did earlier. So getting the counts by origin, doing a bar chart of it. Same way. So here's the SNS.count plot. X is origin. Say Japan. So yeah, this is what we did earlier. And then this is the way to do it with SNS. Then, so here looking at what we were doing earlier, or using the Plotly here as well. So we're creating the figure here, and then plotting it, passing in the axis here. And that's how it knows how to put the seaborne data on this figure instead of just doing like the default one. And then so this one's creating two axes. Let's see what do we get here. So axis 1 and axis 2, yeah. So creating a figure, and then we have two separate graphs for this one. And then the first one is histogram, then we have a scatter plot, and what we saw earlier. So the data is the same. There's just different ways to format it, showcase it. So here, figure level functions, relational plots, scatter plot, line plot, distributions, histograms, KDE, ECD, ECDF, RUG. I don't think I'm actually not that familiar with those ones. And then categorical that we can do. There's different ways. So here's relational, so scatter. Same thing what we saw earlier. And here's the KDT. So we can just call it with the, like instead of calling it SNS dot like his plot, we can do the rel plot or then this plot, and then you have to determine what kind you want it to be. And then here's categorical. So we got our violin charts here. And then, so we can plot the confidence interval, standard deviation, the relational plot, kind is line, and then the CI, which the confidence interval is standard deviation. And these ones, yeah. So whenever there's like deprecated things or whatever, you might get a warning about things. So it's like a feature warning. It's kind of silly because it still does it, but it's just like, it's like, hey, by the way. So you can ignore them and then change your ways for the next time. But yeah, here we are including, so it's a line chart, and then the confidence interval is like the shaded region based on the standard deviation. So cylinders and miles per gallon. Linear regression models. So here we can see weight and miles per gallon. So LM plot passing in data. Get it here. Again, we can specify the hue, the markers. This is the same thing, this one, but we're doing based on the origin. We're doing the line for each origin here for the whole data set, or for each of, yeah, per each origin. This one's a little messy, so probably better ways to represent that, or then just make it bigger or something. Have a plot by origin in 3 columns. So now we have, yeah, so has the USA on its own. We have Japan, and then we have Europe here. So that one is row is kind of like the axis that we saw in PLC before. So just different ways to do this. Then if we want to do like multiple relationships, we can do join plot, focusing on a single relationship. So what do we have? We have weight, MPG, and regular. So this one just shows the shape of the data here. think I've ever seen a data being represented like this. But yeah, there's a lot of things that we can do with this. And if you don't have statistics background or math background, data science background, all of this might be a little confusing, but it's okay. We're just looking at all the possible ways that we can visualize data. You don't have to understand everything about these, you know, the linear regression and standard deviation and whatnot. Don't need to understand all of that. It will come over time. And then join plot. Yeah, so we're just adding the hue here so we can see. So instead of, yeah, we can see it again. All kinds of cool things. So yeah, you can do, like, if you ever, and when you guys were taking Tableau, like, we're looking at data and was like, oh man, like, I wish I could do this, or like customize this part or whatever. Now you will be able to, because you can pretty much like customize anything when you are doing it with pure code. And then we also have pair plot. Let's see, what does this do? Visualize every pairwise combination of variables. So here we see, so gives us every single one. So at the top, and this one might be hard to see because it's pretty small. And I don't know if I can make it bigger because, yeah. So we have MPG at the top here. So each row and each, like, we're pairing every single one of them. So here we have MPG in the first column, and then we have it in the first row, but then we do every single cylinders, displacement, horsepower, weight, acceleration, model year. And same thing here, MPG, cylinders, displacement, horsepower. And then we can add the hue on here to do it based on origin and apply it for each one of these. And this one's just a lot of data too. Oops. Can it do it? It looks like this one has changed. The layout has changed to type. I'm not exactly sure what. The same thing. This one just showcases the same data, but it's just coloring it based on the origin here. So USA, Japan, Europe, the same thing. Get a lot of different graphs. So yeah, different ways to do different things. So we have our pandas library, Plotly library, Matplotlib, and then Seaborn library, and they all have, they majorly can do like the same things, which is different ways of doing things. And then some things might have special things. If you're looking to do something like highly statistical, you probably want to go with Seaborn. Any questions? And we'll we'll do an example at the end. To walk through, kind of put it all together. Okay, so we'll do this, and then we'll do the project or the example. So, and making sure everyone can see this. So customizing plots. So again, we're importing Seaborn, Pandas, PyPlot. I think I've been calling this Plotly. I think that's incorrect actually. Yeah, PyPlot, PLT. Okay, so combining Matplotlib, Pandas, and Seaborn plots in the same figure. So we're creating a figure here. Double axis, PLT subplots, determine the rows, columns, size, constraint layout. And here we're going to set on the X1, we're going to be putting a scatter plot. So this is with the matplotlib of weight, and this is doing the same for all of these. So this is how you do it with pyplot, pandas, seaborn, and then we're just adding a figure here. So here we get, let's see, what do we have? Plotly first here, pyplot, and they're all the same. Just a few differences as far as like here, the seaborn is doing the hue, so for origin, and we could do it with the other ones as well. Takes a little more work. So axis, yeah. So axis Ax1, this is the with pyplot. Ax2 is with pandas. Then we have the SNS on X3 and X4. So this is the same thing, but this last one just has the colors and the legend for that. So you get the same result, just different ways to do it. Any questions on this? Then we can use subplot mosaic to achieve more complex layouts. So if you want to like place them in different places, control the sizes of it. So here we're doing A, B, C, D, and then setting a title for A and a title for B. This is what we can get. And then we can plot data on there. Or then this one, A, B, and then D. So this is kind of like doing the where each one is going to be located on the whole thing. So what we can see is like we have A, B, then we have D in here. So D takes row 1 and row 2 at the end. And then CC. So C takes like 2 columns basically on row 2. So that's how you can place them in different places. And then here we'll do a dot D, which means we're just going to leave a space there. And the same thing, DD, row 1, 2, column 3, and then proceed the same thing. And then adding annotations. So let's see, we're doing so seaborn bar plot. Data df x origin. Is it bar plot? Yeah, annotations. Actually, why is that one already included? Let's see. The means here. I think that's what it's. Yeah. Not fully sure on that one actually. I think it might be just default for seaborn. But we're looking at here. So we want to annotate things. So we're creating our figure, doing the bar plot, passing in the ax in here, then ax annotate. So text. So we're looking at the means from here, and then x, y, horizontal alignment, vertical alignment, color, blue, pbox, and this is a lot of things here. So don't worry about it. You don't have to know everything here. But what we're doing here is we're adding these little labels here, and this is how we're like placing it where they need to go and what the text is. The same way like in Tableau, you would add the label to the chart. So this is how we're doing it in with Seaborn. And it makes it a little more readable. And you can do it with the different, like if we want to put in our markers, pretty much anything you've done in Tableau, we can do it here. Just a little more work. And then, so instead of doing this 3 times, we can use a function, well, a for loop here. So again, we're doing the same thing. We're doing our figure. And this is what we learned in the very first class about loops. So our for loop here, so we do our first, our broad plot, and then for p in ax.patches, ax.annotate. For text, we're going to get the mean here. Is this what we're doing? I think so, yeah. And then xy, get x, get height, color, VBox, and this one doesn't have any. And yeah, so this one, we didn't include like the mean here, the mean string, which we could do that. But this is just an easier way to, because a lot of times, like when you want to start using functions and when you want to start using loops is when you're rewriting code over and over time. And like there's very few things that change. So if you can use variables for those, you can use a loop or function, and it's going to make your code cleaner. And again, you can reuse it. So then less writing and less work for you. So changing style. So here we can see what all are different ways, are the different predefined styles. And this one just lists them out. Classic, fast, ggplot, Seaborn dark, Tableau, colorblind. So plt.style.use. So this is how you set the specific style or the theme. Looking at here, do our figure, plotting the weight and miles per gallon. So this is a very exciting theme. Let's see, for example, what this is. PLT set. So now if we were to do it, it doesn't look any different. Is it supposed to look the same? Let's see, what do we have? Let's try this one. Okay. Very minor changes with these styles. Not very. Yeah, they could. I was expecting something more fun, but they're all kind of boring. Or I'm sure there's, well, I don't know if you have to go find a custom theme to make it more exciting. And here we go. That looks still terrible, but there's different styles you can do. So. And that's how you get it for the Matplotlib library. And we saw we did Seaborn set theme earlier, so there's different ones we could use that one. I think that one was actually more exciting than this one. So then you're probably wondering, okay, so we're doing the plot here. Now what? How can I show it to somebody? How can I put in a report? How can I get it out of this notebook? So we can do, we can just save them as a PNG. So here we're just doing the same thing that we did earlier. Oh, I don't want to use this. Okay, let's see. Which one's a fun one? Give me a fun one, maybe. Probably not a fun one. Let's see, what do we get with this one? It really doesn't matter. So let's see, this one again. No, did that not look? Classic test batch. Maybe we'll just do classic. Oh, interesting. Okay. Oh, that does not look good at all. What did we use earlier? I'll do this one. I'm just playing around with this. That still looks terrible. It doesn't matter. Different ways to do it. But yeah, what we're gonna do, so this one, all the ways you can save it. So plt.gcf.canvas.get supported file types. So we can do EPS, JPEG, PDF, PNG, SVG, TIFF. Those are the most popular ones. So to save this to a PNG file, we're just going to do fig.savefig, name it, and then .png. Same thing, .savefig, to a PDF. So here we get, let me download these. Download, and then downloads, wait. So here we got our PNG, not a pretty one. Would not recommend that one. And then we have our PDF, which is the same size, but yeah, it's just a PDF. So that's how you can save them. Any questions on this? One day I will find a theme that I actually like. Might have to go find like a pastel. That has to be a good one. Maybe. Not really. And then this whole thing got screwed over here. Anyways, anyone have any questions? We will take a, let's see, 8-minute break till, so 8, 10. Yeah. Yep. Be back by 8:10 Central. Is it with me? Yes. Yep. Okay. Cool. Okay. So let's get into this little project here. So we're going to do a little kind of into data visualization project. So starting with come up with questions like, and this is if we wanted to like pick our own data set, but we have picked one here already. But if you were to perform your own little project, you know, what do you want to learn about? What excites you? What's interesting to you? And what do you want to, you know, answer questions to, visualize? So for this one, we're going to be using this UFO data. But if you were to do this on your own data that you're interested in, like we talked about in the very first class, finding data on Google, public data sets on Kaggle, using an API, like you could pull tweets directly from Twitter, or web scrape some data, do a survey, different ways to find data and then visualize it. And then, so we'll look at this data set in a second. But so here we predetermined. So given the data we see, we can refine our questions. What is the yearly, monthly, daily trend of UFO sightings? Which year, month of the year, day of the month has highest number? Which country has the highest number? And is there an overall trend differences by country? So we're going to be importing. So we're going to do our data cleaning first. So importing pandas, seaborn, matplotlib. And then this is the data set, loading it from a CSV. Okay, so let's see our head. I think, can you guys still see it if I make it just a tad smaller to make it easier to fit? Is this still good size? Everybody can see it. So yeah, what do we have? Date, time, city, state, country, shape, duration in seconds, duration in hours and minutes, comments, date posted, latitude and longitude of the sighting. And this one, with the head, you can also, like, if you literally just want to look at one row, we can see it this way. Our columns. And then this one. So what we can see here, there's an extra space in here. So we can just rename it this way, or we could also use the dot strip function to strip any of the extra space. But here we're just renaming it to longitude. Okay, so we're going to check the data types. Every single one of these is an object except longitude. Interesting. So we're going to convert the seconds duration to a float. So df duration seconds, as type float. So we saw this previously as well. Yeah, what happened? Oh, yeah. Don't worry, this is part of the plan. I just forgot. So yeah, what is happening here? We're trying to do it as a float, and so we get value error. Could not convert string to float. So one of the values has this extra character here. So let's see which one that is. So we're going to look at the record where duration seconds equals this 2, and then whatever, I actually don't know what this is called. It's not a quote mark. So here we can see that record 27822, duration seconds, we have that extra character. So what we can do is using the .str.strip, so getting rid of this, and we could also use .replace, passing in this and then passing in an empty string, and that would do the same thing. So now we're gonna retry. and that one worked. We're going to do latitude to a float. We get another value error. Let's see. Could not convert string to float. So we have a value 33q.2000088. And this one, the stack trace, we talked about it a little bit, I think in the first class. I think when you're in like the Jupyter notebooks, reading the whole thing doesn't necessarily bring a lot of value, because especially like if you're only running one line, you know where the issue is. But if you have a whole chunk of code, you don't necessarily know like where the error is occurring, then you kind of want to go through the stack trace. But this one just tells you like what, so this obviously is where the error occurred, but then it's going to show like underneath everything, like what we don't see, like when you call that function, this is what it's like in the like code there. And it would be important if it was like code that you've written, so you can like kind of go through it. But this one, you can pretty much like value error, could not convert it. It tells you exactly what the problem here is. So we're going to do the same thing, look at a record where latitude equals this value that we found. So we see here's the issue. This is our record number. And then, so this one, we're checking between a couple of the different records around this. Here's this one. And what we're just going to do is, so here, instead of using strip, we're using the replace function here. Here's the record. Bring it up. And then we're going to turn it into a float. And that one worked. The next, so we have our date time. And if we looked at it, so let's take a look at this here. So DFD types. So we see latitude and longitude being converted to float. Duration has been converted to float. Everything else is still an object. So in order for us to properly visualize date and time, it obviously needs to be date and time. So we're going to be converting the date and time column to date and time. And again, we have an issue here. And it's probably like, rarely does anybody ever hand you a perfect data set without issues, at least not in my experience. So probably very common to see something like this. So here we see value error, time data, 10/11, 2006, 24:00 does not match this format. So it gives us kind of a couple options. So we're going to see where this is. And obviously like 24 is not a valid date, even in the 24-hour clock, because it would be 00. So we're just going to do it 1 minute before to make sure that it's still the same date. And we could actually do just like 00 here, which could make potentially more sense. But yeah, and then we will give it a try. That one worked. So another thing we can do is like create, so here we're creating columns. So if we want to just create columns for just the year, month, and that was like one of the questions that we were looking at. So yearly, monthly, daily, which year/month of the year and day. So that's kind of indicates that we want to break it into its own columns. So yep. So here we're gonna do df year. So this is adding the year column from DF date and time column. It's a date, so get the year. Same thing for month, get the month, get the day. So, and then we can do here. So here we have added year, month, day, and they're all integers. So if we were to look at their DF, we'll see, oh, let's go ahead. So we see year, month, and day have been added here. Any questions so far? If I'm going too fast, I have tendency to do this sometimes. Everybody's still following. Just doing a little bit of changing data types, cleaning out little errors. Okay, so now, let's do some visualization here. So what we saw earlier, so creating a figure, an ax, PLT, subplots, big size, 14:5, constraint layout. Then we're going to create a histogram on the date and time. So here, what we can see is that these have become way more common after in the 21st century. Not a whole lot happening here. So that's why I'm going to look at that. Okay, so this one was, what is the overall trend of UFO sightings over time? So we're saying it greatly increase as time goes on. I wonder what, like, yeah, very interesting. Anybody see any UFO before? Apparently, I have a friend who works in like the defense industry, and like she said that they've actually proven that there are like UFOs, like there are materials in space that have been like, it's made out of something that does not exist on the planet. And I don't know if I believe that, but apparently they've proven it. So I don't know about that one. Not aliens though, but UFOs. So just something strange that's going on. Okay, so looking at which year has the highest number of UFO sightings. So we're going to do DF year, and this is the same way. If you remember, we can do either dot year, or then we can do use the brackets and then wrap this. Oops. And that counts. So here we see, is that the earliest maybe? So 1 UFO sighting per year over here, and then we have 10 in 2012. Oh, interesting. Didn't they say like the world was going to end in 2012? Did not happen. All right, and then, so what we're going to do here is plot this. So count plot, year is greater than 1980. X-axis is year, setting the X label to year. X ticks, rotation. So this one is the tick marks here, so the year. This one rotates them to be vertical. If we didn't do this, they're this way. And if it's like any longer words, they would start overlapping. So rotating it, and you can also do a rotation 45, and then it's going to give them like this, which I think this is like, again, if you have longer, this is a good way so they don't, because it's harder to read if they're fully vertical. I think I like this one without a rotation actually. Yeah. So here we can see very little and then a whole lot. So 2012 had the most sightings. See, this is a nice theme right here. It's pretty. All right, and then looking at the head again. So which day of the month has the highest number of UFO sightings? Again, looking at per day. And the same thing here, creating a figure, setting day of the month. And then here we can do our annotations. So we're adding it here. And that one's a little bit messy. I think this one, let's see. Let's see how we can, and this is also, let's see, we're seeing overlapping. And this one was, is this a float? Let's see. I think so. DFT types. Was it able to count? Yeah. Yeah. Count plot. Okay, why is it? Take height, get X. This one, I think, can we just do round in here? And this is like, you know, I don't use visualizations a whole lot, but like we could go ask ChatGPT. This is, I will show you guys an example actually. Like if you have not, what I often do, because I think a big thing in what AI is like being able to do the proper prompts and stuff. But like here, what we can do is like, oh, we have, let's do, usually what I do, let's do DF2 CSV. So whenever I'm like stuck with something, don't know exactly how to do something, this is usually the steps that I take. Do CSV. And we're going to name it UFO.csv. And let's see. Oh, missing that one. There's a UFO CSV. Download it. And what you can do with, and we can, I pay for the premium so I can explore all these things. So we have Python. And what we can do is, so desktop UFO CVS. So what we could do is like, I have the, or like, I am creating visualizations for the attached dataset. And this is my code. I already have the following code. How can I, let's see, what do we want to do? Make the labels integers. And that's like the important part. And I think Nate is planning to teach a prompt class as well, which I bet that will be really interesting because there's like a science to it. You have to treat it as a friend. And is this going to tell us? What a great time to be alive, honestly. So here, what we're doing, let's see if, and it's not always right. So let's see what we get here. So if we're going to replace, they wrote the whole thing. Yep. So we're going to replace this. Let's see, what do we get? Oh, look at that. It worked. Now, if we wanted to ask it to like, how can I make the labels bold and blue? I don't know if you can probably make it bold. Just like set the weight of the font. Font weight, yeah. Color. Now we can use this. Oops. And now they're bold and blue. You guys can see that. That's probably pretty small at this point. Let's see. There we go. Yeah. So that's how I usually use like ChatGPT to, depending on what I'm doing, usually my projects and stuff, because it's smart. You can upload your data to it. However, if it's company data, do not upload it there. Don't do that. Because there's people who do that. At that point, just ask generic questions. But yeah, that's the one way to do it. All right, let's see. Yeah, so continuing on. So yeah, what did we learn here? So by using the color, and this one, the thing is, you can go to the documentation and find this, but like that was so much faster. So work smarter, not harder. So this one we're doing, and this one's the alignment, looks like, and then color, font weight. Those are different arcs that we can put in there. So moving on. Do the same thing by the month. And then what did we learn here? We can do this to get the, let's see. I think it's, nope, that's not the one. Oh, yeah, here, this one. Int. And we have to use it to do the string formatting for that one. That makes sense. And now it's in, we get the integer values. What did we saw here? Day of the month, the 1st and the 15th. Quite interesting. And then for the months, we have mostly July over the summer. That makes sense. But it doesn't make sense. I think like in Finland, because like, for example, in June, we have nights that it doesn't get dark at all. So like, would you be more likely to see a UFO when it's super light out at night or super dark at night? So I wonder if that plays into that. Lots of questions. Then we can look at which country has the highest number of UFO sightings. So we're using the longitude and latitude here. We're going to do a scatter plot, alpha for the transparency. And here, and this one, if we were to place it on like, get a, like an actual picture of the world and like place it in there. But here we could see like, clearly North America has a lot of sightings. A little bit here. I think UK is right here. Central Europe. Australia? New Zealand? This is probably Hawaii. I think that does that. I think so. I think it's Hawaii right there. And yeah, here. There's different ways to plot this. We're not going to go them over. This is just one way with the latitude, longitude and latitude. And then let's see. We'll do, so per country, we're going to look at, yeah, so here we can see US, Great Britain, Canada, Australia, DE, Germany, I think. Yeah, that's the country code for Germany. So the most in here in the US. I wonder what that means. Overall trend differences by country. So let's see, we're going to look at the KDE plot, Q by country. Over time. So yeah, US is leading the way. And then lastly, let's see. This is looking at for each country, for each unique country, KDE plot when the country equals C. Yeah, so this is just doing it. We're looking at the KDE, the density. And that's just different ways that we can look at. Anybody have any questions? This is kind of like the walkthrough when you do. And I would do that. Find a data set, something that you're interested in, whether it's like, oh, like, I don't know, bicycle manufacturers, or like cars. There's a lot of data on like health, fitness, food, and then like come up with some questions and do your data cleaning, and then do your comment accept. Do your visualizations, which you can obviously do with Tableau, but to practice your Python stuff. Any questions? Anything that you want me to like go over? Something wasn't clear enough? I need to figure out where this theme came from. I like that one. Let me see. Visualization, yeah, Plotly. That's all I have planned for today. So we can, if nobody has any questions, we can end the class a little early. And I will drop for the example that we walked through earlier, I'm going to drop that into the, I saw a couple of people who had requested access to the shared folder. You should, if you have a Google account, you need to log into a Google account. If you don't have a Google account, let me know and I'll just add you by email. But it should be like you open the link and it's going to be like request access. If you have any problems with that, let me know. But I'm going to be dropping like these files into there, and I'm going to drop the example that we walked through earlier for data cleaning, and I'll drop like 2 versions of it. I'll drop the one that's like how like plain clean everything and you can walk through it yourself, and then I'm going to like include the notebook with the answers. And you can do it, you can either upload it here on Anaconda Cloud by clicking this. So this one, you can go find a notebook and include it in here. Or if you want to use what I was using earlier with like this version, which is the like local Anaconda, I can walk through that real quickly since we have a few minutes. So Anaconda, not Anaconda Cloud, we're just going to do anaconda.com. Yeah. So Anaconda Cloud, let's see, solutions, free download, distribution. So you don't have to register for this. Download for Mac, Windows, Linux, whichever one you have. And then just click next when you're installing it. Nothing interesting there. And this is what you're going to be downloading. So Anaconda Navigator. And you don't have to be logged in to this one. And as you saw, like you can skip the registration. So here, you're gonna do Jupyter Notebook. This is what we're using. So launch. It's going to open a couple terminals, and then this is the location. Oops, this is my. Let's see. This is what it's going to open. And you can also copy this address right here. This is where it's going to open this. So here, so mine was here. Let's see, Python, data cleaning. So here, it kind of opens like your directory for everything. And then this is where your notebook is. And it works exactly the same way as Anaconda Cloud. You can access when you're reading the CVS, just make sure that it's in the same directory. Or if it's not in the directory, you'll have to like you can either put the full path and whatnot. But that's how you can open the notebooks that are in the shared folder. Anybody have any questions about that? So anaconda.com, and I can put these instructions in the Slack as well. But anaconda.com/download. That's where you get the navigator. And you don't have to, but if you like to, you can, because you can upload them here as well, and it'll work the same way. Either one work. But make sure, like, if you are gonna do that project here, to also upload the data set up here. Otherwise, it's gonna say it doesn't exist. Any questions on that? Any questions on anything? No questions? Okay. We can end class a little early, and I will see everybody on Wednesday. And we will continue on our Python. All good? Okay. Have a good night, everybody.